Hello students, in this video we are going to solve a real-life problem that involves exponential functions. The problem is taken from science. Kristen starts an experiment with 7,500 bacteria cells. After 4 hours there are 23,000 cells. Question A is looking for: write an exponential function that could be used to model the number of bacteria after X hours if the number of bacteria changes at the same rate. So at the beginning of the experiment, the time is 0 hours and there are 7,500 bacteria cells. So the y-intercept, so I'm writing the y-intercept, in this case is the value of A, and A is equal to 7,500. Now when X equals 4, the number of bacteria cells is going to be, Y is going to be 23,000 bacteria. Now we have to write an exponential function that could be used to model the number of bacteria. And we know that the formula for exponential function is y equals a times b to the power of x, where a represent the initial value, y represent the final value, b represent the factor of growth or decay, and x in this case is the time. As you know, the bacteria after 4 hours is going to be 23,000. So instead of y, I am going to substitute 23,000. The initial value is 7,500. We don't know the growth here. You see that you start with 7,500 to finish with 23,000, so the bacteria is growing. So we are dealing with exponential growth, but we don't know the factor of growth, and all of this process is happening in 4 hours. So I'm substituting x with 4. Now here we are dealing with an exponential equation. To solve that exponential equation, we have to divide both sides by 7,500 to leave the b alone. And on the left side, I have 3.067 equals approximately, I'm not going to say exactly, b to the 4th power. Now, we have to take the 4th root of each side in order to leave the b alone. So I'm taking 4th root here and 4th root. And to take the 4th root, you have to use the graphing calculator, the keywords, you press 4, you go math, and you find x root, which one in this case is the 4th root of this number. After you take the 4th root of this number, b is approximately, take a look on my side, 1.323. But remember, I'm not done because the question here says write an exponential function. So I found the b, which one in this case is the factor of growth. You can tell that b is greater than 1, and when b is greater than 1, we're dealing with factor of growth. And now I'm going to write the final equation. I say y approximately 7,500, that is initial, the factor of growth 1.323 to the power of x. So this is the general form of the equation. I put this in a box, and I finished the first question. Now let's go and read the second question of this problem. The second question B says, how many bacteria cells can be expected in the sample after 12 hours? Okay, so now the time is not 4 hours anymore, but it's 12 hours. And I have to find the number of bacteria that is in 12 hours. It's so nice that I can use the formula that I just found before, and I can say y, always approximately. I will take the initial again. The initial didn't change, it's 7,500. And the factor of growth, I just found the b, 1.323 to the power of x. And x in this case is 12. So instead of x, I substitute 12. copy the rest as it is, 3 to 3 to the power of 12, and gives me approximately the number of bacteria, which one is 215,665. And my final answer here is there will be approximately 215,665 bacteria cells after 12 hours. The answer makes sense since the number of bacteria is increasing in a factor of 1.3.23, and the number of bacteria in 12 hours is much bigger than the beginning that we started with only 7,500. We are dealing here with an exponential growth. Thank you.